So this chapter deals with different transformations. Okay, we've talked already about one transformation back in chapter 7. We talked about dilation, and remember, a dilation is when a figure is reduced or enlarged. Okay, um, the other ones that we're going to talk about in this chapter are the rotation, the reflection, and the translation. Okay, these are called mappings or transformations, and it takes a pre-image and it maps it onto an image. Now, if you remember back from when we talked about dilations, your pre-image is what you start out with, and your image is what you end up with. Okay, and so again, this one, as you can see, is a reduction. This is a rotation. This next one is a rotation. It's a looks like about a 90-degree rotation clockwise. Okay, we'll talk more about that. Um, rotation is sometimes called a turn. You have your translation, which is also a slide, and that's when you take and you move something left, right, up, down. Sorry. And then you have your reflection or your flip, which is what we're going to talk about today, and that's when you take and reflect something over a line of reflection. Now, the ones that we're going to talk about are considered isometries. You need to know that word, okay? An isometry is a congruence transformation, and that's when it takes your pre-image and it maps it onto an image, and the two images are congruent. They're exactly the same, okay? The dilation that we talked about back in chapter 7 is a similarity transformation, and the pre-image and the image are similar, okay? But in an isometry, and what we're going to talk about the next couple days, these are congruence transformations, okay? So today we're doing the reflection, also called a flip. This right here can be read A, B, C, D maps onto A prime, B prime, C prime, D prime, E prime. Now we use the primes to represent the image. All right, that means that we've taken the A, B, C, D, E and we've mapped it to a new location. That's why we put a little prime right there. You can see here this little pentagon has been reflected over the line of reflection, okay, onto A prime, B prime, C prime, D prime, E prime. Now the thing that when you reflect it, you have to preserve the distance to the line of reflection. So like the distance from E to the line of reflection has to be the same as the distance from E prime to the reflection, okay? And the same would be true from A to the line of reflection and A prime to the line of reflection. Those have to be the same. If they're not the same, then the figure gets mixed up. It no longer stays congruent, okay? So you have to preserve that distance there so that the shapes are exactly the same. All right. So here's an example that we want to do, and there'll be one like this on the test. You might want to put a little star by this one. You'll have some problems like this. You have triangle JKL, and it has the following vertices. It says graph it and its image in the given line. All right, so what we're going to do is we've already graphed the pre-image. Now we want to graph the image, but we want to reflect it over the line x equals -4. What does the line x equals -4 look like? What kind of line is that? Vertical. Okay, remember, if you cut the x in half, you get a V, so it's a vertical line. It goes through -4. So you come over here to -4, and you draw a line through it. Okay, this is the line x equals -4. And so what you want to do is you want to reflect each point over it. And again, you've got to preserve the distance. So if you look at point L, it is 2 units to the left of that line. So when you reflect it, it has to be 2 units to the right of that line. Okay? The same with J. J is 1, 2, 3, 4 units to the right. When you reflect it, it's going to be 1, 2, 3, 4 units to the left. And then K is 3 units to the right. So when you reflect it, it's going to be 3 units to the left. And so then we connect our points, and we have flipped or reflected it over the line x equals -4. Now let's make up another one. Everybody got that written down? Let's make up another one. This time, let's reflect it over the line y equals -2. Okay, erase it. Everybody got this? I'm going to erase it. Okay. So let's say that they ask us to reflect it over the line y equals -2. What kind of line is that? Horizontal through -2. So we go to -2 on the y-axis, and we draw a line through. Okay. So if we reflect this time, K is 1 unit above, so it becomes 1 unit below. J is 1, 2, 3, 4, 5 units above, so you have to go 1, 2, 3, 4, 1, 2, 3, 4, 5 units below. And then L, it looks like 3 units above that line, so you got to come 3 units below. Okay. So we have reflected over the line y equals -2. And it's important to graph the pre-image and the image. That way you can compare, and if it looks like it gets distorted, then you've made a mistake, okay? Because it should preserve its congruency. All right. Now let's talk about reflecting over the x-axis and the y-axis. These we're gonna graph if I can, and then we're gonna look for a pattern that's formed. Okay, so we want to first reflect over the x-axis. Here's my x-axis. And it's going to be just like those previous problems. You look at its distance from that line of reflection. And we'll start with K. K is 1, 2, 3, 4 units below. So when you reflect it, it becomes 1, 2, 3, 4 units above. Okay, and those coordinates are 2, 4. If I look at L, L is 3 units above that line, and so it's going to be 3 units below. And so its coordinates are going to be -1, -3. Can you see a pattern of what's happening with my coordinates? What happens? Here it was 2, -4, and when I reflected it became 2, 4. Here it was -1, 3, it became -1, -3. Okay, so to the y, right. If you reflect over the x-axis, the sign of the y coordinate changes. Okay, so my pattern is, if you take your x and y coordinate, your x stays the same, and then the sign of your y changes. Okay, so if m was at -4, 2, what's it going to be? -4, -2, okay? And n prime would be what? -3, +4. So let's graph both of those. -4, -2, that's n prime. And n prime, 1, 2, 3, 1, 2, 3, 4. Okay. All right, so then we connect our points. And so we have reflected over the x-axis. All right, and so when you reflect over the x-axis, the sign of the y changes. Yes? You can. I'm not going to be super picky about that, but if that's something you want to do, that will help you, like, make sure that, you know. All right, now we want to reflect over the y-axis. So again, we're going to graph a few, and then we're going to look for a pattern and see what's happening. Now, the y-axis, here's the y-axis, so we're going to reflect over that. And so we look at K, and K is 2 units to the right. So if you reflect it, it's going to become 2 units to the left. So then my coordinates become -2, +4. If I look at L, L is 1 unit to the left. If I reflect it, it's going to become 1 unit to the right, which is going to be 1, 3. What's happening this time? The sign of the x changes, right? So you take your x and y coordinate, and the x changes sign. Okay, yes?
How come it's a positive?
What? On K, why is it what?
Why is it positive?
Because I reflected it. Oh, thank you. I just wrote it down wrong. Thank you. Yes, -2, -4. Yeah, you changed the x, not the y. Sorry about that. All right. So what would I do to m prime?
Oh, no.
4, 2, right. Okay, and then n prime would be 3, -4. Okay. All right, so if we graph those, 4, 2, 1, 2, 3, 4, 1, 2. There's my n prime, and my n prime is 1, 2, 3, 1, 2, 3, 4. Okay, so I've now reflected over the y-axis. So if you reflect over the x-axis, your y-coordinate changes sign. If you reflect over the y-axis, your x-coordinate changes signs. Okay, so they kind of have the opposite relationship there. All right, now we want to reflect over the line y equals x. What does the line y equals x look like? Come on, guys. You learned how to graph last year. We talked about graphing in here, back in chapter 3. If you don't know how to graph something, what should you do? Nobody has any clue. We have failed. Make a table of values. Can you do that? Make an XY chart. Give me values for X. Give me values for Y. That's one thing you can do with anything, correct? If you have an X and a Y, you can always do that. Okay, that's a lot of work. Okay, yes. It is diagonal, right? Okay, we can go and use our Y equals mx plus b. Okay, so what's my slope going to be? 1. And what's my y-intercept? 0. Okay, so it goes through the origin, and then it has a slope of 1. So it rises 1, it runs 1. Okay, so your line is going to look something like that. Okay, all right. Now reflecting over a diagonal line is a little trickier because you got to kind of come at it perpendicularly because we're talking about distance. So if we look at K, we would have to go diagonally across the square, and that's 1, 2, 3 units. So then we have to go diagonally again, 1, 2, 3 units. It's actually going to be where M is. And so those coordinates are 1, 2, 3, 4, negative 4, 2. If we look at L, again, we got to go diagonal. So 1, 2, and then we go 1, 2 on the opposite side. So those coordinates are 3, negative 1. What does it look like is happening? Okay, the coordinates are flipping, right? So you take your x and your y coordinate, and when you map it, they switch places. So what would the coordinates for m prime be? Okay, 2, negative 4. Okay, and the coordinates for n prime? Negative 4, negative 3. Okay, so 2, negative 4. My n prime is going to be down here. And my n prime, 1, 2, 3, 4, 1, 2, 3. Okay, so where's my other point? Did I do? Oh, I didn't graph L, did I? 1, 2, 3. Oh yeah, here it is. I just didn't label it. Okay. All right. So we have now reflected over the line y equals x. Okay, so that's reflecting over the line y equals x. What about the line y equals negative x? What is it going to look like? It's going to go diagonal, but the other way, right? Because again, if we look at our equation of a line, my slope now is going to be negative 1, and my y-intercept is going to be 0. So it's got a negative 1 for a slope, still goes through the origin. So it's going to look something like this. So when I reflect, again, I go diagonal. I'm 1 diagonal unit from the line here for K, so my K prime is going to be right there. Those coordinates are going to be 1, 2, 3, 4, negative 2. Okay, L, go 1 unit diagonally, go another unit diagonally. There's my L prime. Those coordinates are negative 2, 1, 2, 3, negative 3, 1. What do you think is happening here? The signs and the coordinates switch. So if we take my x, y, they switch places, but they also switch signs. Okay, so they flip-flop places and they change signs. So what would m prime be? M prime. Negative 2, 4, okay, and n prime would be 4, 3. Okay, so negative 2, 1, 2, 3, 4. And in 1, 2, 3, 4, 1, 2, 3. And so now I've reflected over the line y equals negative x. All right. So I came up with a little chart here that kind of summarizes it for us. Takes my pre-image onto my image, okay? If I'm going to reflect over the x-axis, I change the opposite coordinate. I change the y. I change the sign of the y. If I'm going to reflect over the y-axis, I change the sign of the x. If I'm going to reflect over the line y equals x, the y and the x switch. And if I'm going to reflect over the line y equals negative x, what happens? They switch and change signs, both, right? Okay? Not hard, right? You just follow those little things, kind of memorize it. And if you can't remember, you can always draw it, right? And count it. Now, don't forget about this, because there's not really a rule for this first problem that we did. You actually have to graph it, you have to draw the line and reflect it, okay? You have to actually do that one by hand. There's not necessarily a rule for that one, okay? All right, any questions?